Hello everyone. Scanning probe microscopy. Today we'll study scanning probe microscopy. This scanning probe microscopy is a new branch of microscopy that forms images of the surfaces using a physical probe moving or you can say that physical probe that scan the specimen. An image of the surface is obtained by mechanically moving the probe in the raster scan of the specimen line by line and recording the probe surface interactions as a function of a position. So there are several types of scanning probe microscopy, and today we'll study one of them, that is atomic force microscopy. So first of all, let us see what is atomic force microscopy. It is also known as AFM, and it works by scanning a probe over the sample surface, building up a map on a height or topography of the surface as it goes along. You can just look at the surface that the cantilever beam, the tip is touching the surface of the sample, and reflection of light is being detected. So in the last slide, we have seen that AFM works by scanning a probe over the sample surface, building up a map of the height or topography of the surface as it goes along. Now, what is AFM? So the atomic force microscopy or scanning force microscopy was invented in 1986 by Benning, Quet and Gerber, which is quite similar to the scanning probe microscope. And the AFM raster scan a sharp probe over the surface of the sample and measure the changes in the force between the probe tip and the sample. And it permits resolution of individual atoms on both conducting and insulating surfaces. This is very much important application of AFM, in which a flexible force sensing cantilever stylus is running over the surface of or measure the raster pattern over the entire surface of the sample. Now, what are the physical parameters? If you want to know what are the construction of AFM, then there are important parts of AFM. Let's see one by one. The physical parameter probed is a force resulting from different interactions. The main important principle of AFM is the interaction between the tip of a cantilever beam and your sample. So the origin of this interaction can be ionic repulsion between the tip and the sample. It can be van der Waals forces, electrostatic and magnetic forces as well, or elastic and plastic deformation. Thus, an AFM image is generated by recording force changes as probe is scanned in XY direction over the sample. Now the sample is mounted on a piezoelectric scanner, which ensures three-dimensional positioning of the sample to get higher resolution. The force is monitored by attaching the probe to a liable cantilever. So let us try to understand the working concept of AFM. The physical parameter probed is a force resulting from different interaction. The main important principle of AFM is that interaction of that tip with the sample, and the origin of that interaction can be any kind of forces. So here it has been mentioned that the origin of this interaction can be ionic repulsion. It can be van der Waals forces, electrostatic and magnetic forces, or elastic and plastic deformation. Any kind of the forces will act between the tip of the cantilever and the sample, which can be detected by AFM, and from that we can get the information of topographic information of the surface of the sample. So this AFM image is generated by recording the force changes as the probe is scanned in the XY direction of the sample. This is very important. The probe is scanned on XY direction of the sample, and that has been recorded. The force acting between the tip and the sample. The sample is mounted on a piezoelectric scanner, which ensures three-dimensional positioning with high resolution. The force is monitored by attaching the probe to a liable cantilever, which acts as a spring and measuring the bending or deflection of the cantilever. Just look at the image of working concept of AFM. There is one cantilever beam. you can see that there is a scanner, which is a piezoelectric scanner on which the sample has been mounted, which has been shown on a as a gray color, and there is a cantilever beam. At the end of the cantilever there is a sharp tip. On that sharp tip laser, generally the light which is used here is laser light, and when any kind of force acting between the tip and the sample of the sample, according to that the deflection of the light will take place, and photodiode, the photodetector will detect the deflection of the light, and that can be directly related with correlated with the interaction, and the force is acting between the tip and the sample.